Welcome to the tutorial on Rainsphere, an integrated system for global satellite precipitation data and information. The precipitation information provided by Rainsphere covers two aspects. First is the historical satellite rainfall data PERSIANN-CDR, which is produced by CHRS at UC Irvine and released through NOAA National Centers for Environmental Information. PERSIANN-CDR is a high-resolution dataset available at a daily time step and 25-kilometer spatial resolution for over 3 decades. Second, for those interested in model projections, is the presentation of IPCC CMIP-5 future precipitation projections.
This tutorial covers various features of the system, beginning with an overview of the Rainsphere interface. On the left panel, there are 6 main sections. These allow users to choose desired map layers to display, choose whether to look at historical precipitation estimates from satellites or future precipitation projections for models, visualize global precipitation for any time period within the display, compare the difference between 2 different rain layers, query statistics for a specified region and time, and view past and future rain trends. A location reference map is also provided for easy navigation, as well as a search bar to pinpoint specific locations. The base map can be adjusted according to viewing preferences, and the map itself is interactive for location selection.
Several varieties of map layers are available to aid in data viewing and selection. For human-defined boundaries, we can display country borders, or at the finer scale, we can display other political boundaries such as states and provinces. Hydrologically, we have 4 levels of spatial divisions, starting with the largest, which is continental basins, then down to major river basins. We can go to even finer divisions with the tributaries option, and all the way down to individual watersheds. Now for the rain layers. As an example, we'll take a look at historical precipitation. Let's turn on our country map layer for reference and make sure the data type is set to historical. For this exercise, we'll look at total precipitation for a time period, so we select the accumulative button. Now let's put in a time period, 1 year of historical data. We hit submit and get a complete global picture of the total precipitation for the year 1983. With this and any rain layer, right-clicking on a point displays the estimated precipitation value of that pixel. We can also toggle on or off any rain layer for which we have previously searched.
If you desire to compare 2 different rain layers you've created, you have the option to compare them side by side with the Rain Layer Comparison tool. Choose Side by Side from the scroll bar and click Compare to bring up 2 dataset maps positioned as one continuous map. We'll also select country layers to more easily compare data in the same location. You can choose which dataset you would like to see by choosing it from the scroll bars labeled Left Window and Right Window. Here we're comparing the total climatology versus the climatology for 2013. You can drag the dividing line left and right to change the sizes of the maps. This is very useful for comparing the sizes and changes in the data. For example, we can easily see how abnormally dry 2013 was on the West Coast by dragging the dividing bar over the region. If you zoom into or drag the map in one window, the map in the other window will snap to place to maintain a continuous map. If you'd like to freely move both parts of the map separately, click the padlock button on top of the dividing line. Once the button appears unlocked, you can freely drag either map without influencing the position of the other map. This is very useful for comparing the same areas side by side without the need to drag the center line over. You can also select Difference from the drop-down menu under the Rain Layer Comparison tab to calculate and map the relative difference of rainfall for your 2 datasets. If the amount of rain in Rain Layer R1 is greater than in Rain Layer R2 for a region, then the map will display the region as red. Likewise, the map will display the region as blue if rainfall in Rain Layer R2 is greater than that in Rain Layer R1 for that region. You can right-click to get a value for the relative difference of that pixel.
The automated statistics capabilities of Rainsphere is one of the most powerful features of the system. Let's start with an example of querying annual statistics for a country. Under our Query By menu, we select Country and a yearly date type. Let's go ahead and select the entire historical period for evaluation. Now we click on a country using the interactive map and see the automatically generated report with basic statistics. We can toggle on or off the linear trend and average markers, depending on what we want to visualize. A Mann-Kendall test of significance is shown with each trend. In this case, the United States shows a decreasing trend in precipitation for the entire historical period. However, this trend is not statistically significant. For other examples, China shows virtually no trend, and Uzbekistan shows an increasing trend for the same time period. We can also include the temperature of our location of interest on our graph and use the mouse to hover over a point on any plot displayed for an estimated value. We have the luxury of exporting the chart data to a CSV file or an image file.
If we scroll down, we can view a map of the average climatology of the selected region.
If we like, we can view the individual rain images for our area to get a sense of spatial pattern changes through time. Again, hovering with the mouse over the precipitation images displays the estimated precipitation amount for a pixel in that image. Additional location-specific information is provided in these reports. From these, we can see distributions of aridity, land cover, and elevation. To grab the entire report, click the Export button on the bottom. We can perform a similar analysis for a political division query. For an example, let's look at a complete historical period for the state of California. In this case, California shows no significant annual precipitation trend. What we can see very quickly is how dry the year 2013 is. In fact, it had less than half the average annual rainfall for the state. Now, let's quickly look at a location query. Again, we will select the yearly rainfall for the entire available data period. Begin typing a location in the search bar, and locations matching your search will begin to populate the list below. Click on the correct match to drop a pin on the map. Clicking on the pin will then bring up the statistical report for your location.
Next to the Rain Statistics tab is the Rain Trend tab. Click it to see the trend of rainfall from 1983 to the present year. Blue indicates a positive trend or increase in average yearly rainfall, while red indicates a negative trend or decrease in yearly average rainfall. Right-clicking a pixel will bring up the rain trend for that area. These trends can be seen in different spatial scales from pixel resolution to various political and hydrological boundaries. Here we'll choose to see trends by country. Next by political divisions such as states or provinces. And now by major river basin. Some of these larger regions may be overlaid with hashed lines. These indicate that while there may be an apparent trend in rainfall, it is not considered statistically significant.
Switching now to future mode, we look at IPCC model projections. Select the Future IPCC Projection button to examine future precipitation projections up until the year 2100. Visualization features are largely the same as historical observations, except now we notice a visualization of 1 year, for example, brings up 3 data options. These correspond to 3 different carbon emission scenarios, all of which can be downloaded individually. We will now step through a major basin statistics query example for future projections. For the example, we select major basin as our query type, and for something different, let's check out how precipitation for a single month is projected to change from now until 2100. If we click on the Mississippi River Basin, now we see plots for 3 emission scenarios. In this case, the low emission scenario suggests a decreasing precipitation trend, and the stabilization and high emission scenario suggest an increasing precipitation trend for this basin.
Rain trends can also be predicted from the present to the year 2100. With the Future IPCC projection option selected, click on the Rain Trends tab. There will be 3 options for the projections, each relating to the 3 different carbon emission models mentioned earlier in the video. Like the past rain trend map, blue and red indicate a positive and negative trend respectively. Likewise, the trend data is also viewable in pixel-by-pixel resolution or by political and hydrological boundaries, with hashed lines indicating no statistical significance.
Thank you for watching this tutorial on Rainsphere.